in this we will discuss on ID representation and simulation. Okay, the ID representation, okay, it should like LHS tends to RHS. LHSல பொறுத்த வரைக்கும் பார்த்தீங்க அப்படின்னா 3 attributes இருக்கணும். என்னென்ன attributes? First one பார்த்தீங்கன்னா state, the second one is total number of string, third one is top of the element. சரியா? RHSல என்ன இருக்கணும்? Resultant state அப்புறம் status of the stack. சரியா? இதுதான் வந்து ஒரு ஐடி ரெப்ரசன்டேஷன்ல இருக்கணும். ஓகே, LHS tends to RHSல 3 tuples, அதுக்கப்புறம் 2 tuples இருக்கணும். ஓகேவா? இப்போ வந்து நம்மளோட எக்ஸாம்பிள் பார்த்தீங்க அப்படின்னா CNF ப்ரொடக்ஷன்ஸ். ஓகேவா? அந்த CNF ப்ரொடக்ஷன்ஸ்க்கு we going to see the ID representation. First, initially, okay, we are writing the ID representation in terms of LHS and RHS. Okay, initially there is no state to be defined, so I'm writing here as Q. Okay, the total number of string to be read by the head pointer, that also don't know, and starting stage, so I'm writing here as W. W in the sense it is set of string. The next one is top of the element. Okay, initial stage, the top of the element is Z0, in the sense there is a no element which is present in the stack. Okay, that representation we are representing here as Z0. Okay, and RHS, what we'll do is first we'll write the resultant state. Okay, there is no input which is read by the head pointer, right? So that there is a no resultant state. So I'm writing here same as the LHS state. So I'm writing Q, right? The next one is status of the stack. Okay, that is the total elements which is present in the stack, in which I'm not performing anything here, right? Performing anything here in the sense I'm not reading any input. Okay, and I'm not performing any operation, push operation or pop operation. I'm not doing anything, right? So the stack, the total number of elements of the stacks is just like that before, right? That is the status of the stack is Z0. This is the condition of the initial stage of ID representation. Okay, now we're going to, okay, implement the productions one by one. Okay, in which what we're going to do is first we should look on the first production. All right, what is the first production? The first production is S tends to AB, right? S tends to AB. My first production is S tends to AB. Okay, in this first production, okay, look at the diagrammatic representation. What they are doing, first they are pushing the S into the stack and pop out the S from the stack and pushing the element B and pushing the element A. Okay, these are all the process they are doing for the production S tends to AB. The same thing we should handle for ID representation also. First, what we have to do? First, we have to do the operation of push operation, right? So in this I'm taking the state from the RHS of the first step, so that is Q. So I'm writing here as Q, and I'm dealing about the only the production. Write this position, I don't know the string to be read by the head pointer, so I'm writing the total number of strings as w, right? At this point, there is top of the element is z naught, okay? And resultant states I don't know, because I don't know the total number of inputs here. So after reading the inputs with the particular state, then only I get to know the resultant state. Here I'm not able to know what is the resultant state, so I'm writing as the same state as LHS, right? Then now I'm writing here the status of the stack, okay? In this step, what I'm doing is I'm performing the push operation, that performing the push operation, push S. So I'm pushing the S into the stack. So I'm pushing the S into the stack, okay? Then what I have to do is, then I need to perform the pop operation, that is pop is I need to perform, right? So I'm performing the pop operation here, okay? Performing the pop operation, performing pop operation in the sense S will be removed. So the status of the stack is Z naught, okay? From which I'm writing, okay, this one I'm writing, okay, this is the state, okay? And the next one is I don't know this string, okay, what are the string to be read. And now I know, okay, before that I'm writing, now I know what is the top element of the stack. Top element of the stack is, before performing the operation of this step, I'm writing the top element from the stack. The top element of the stack is yes, so I'm writing yes here, right? In this is RHS only I'm performing the pop operation. If I perform pop operation, okay, the S will be removed. So I got the total number of element is Z naught. So I'm writing status of the stack is Z naught. Okay. Then what what operation I have to do? I need to look on that this production diagram. Then I have to perform the push operation of B and A. Okay, first we'll perform the push operation of B and A. What is in this? I'm doing the push operation B, and here I'm doing the push operation A. Right? Push operation B in the sense, in this line I need to write the state. First I'm writing the state what I achieved is just I'm writing here. And this is total number of state. In this I don't know what are all the total number of inputs, I don't know what are all the inputs. And the top of the element is, before this step, what is the status of the stack. That from that I need to write the top of the element. Top of the element is Z naught, okay? There is no resultant state, so I'm writing same as Q. And okay, now I'm performing the push operation. Push operation I'm performing means the B will be pushed into the stack. Already there is a one element Z naught is present. Now I'm pushing the B. So the status of the stack will be B Z naught. Okay, in this next step, in this step, I'm performing the uh, push operation. That is, I'm pushing the A into the stack, okay? So what all resultant state I got before, okay, that I'm writing here in the LHS of this step. So next one is total number of inputs. Here in this step also I don't know what are all the total number of inputs. In this stage also I don't know what are all the inputs, okay? Next I need to write the top element of the stack, okay? I need to look on the stack position. What is the top element? The top element is B, so I'm writing here is B, okay? In RHS I need to write the resultant state. Till now I don't know what are all the inputs, so I'm writing the same state as LHS. And in here only I'm performing the push operation A. So if I perform the push operation means the A will be insert into the stack. Okay, now this status of the stack will be a b z naught. Okay, next step. Next step, what I have to do? Okay, next step, what I have to do is I need to look on the derivation part. Okay, derivation part in the sense, derivation part in the sense derivation will be carried out from the initial state, that is start state. In this I need to substitute the this. If I substitute this means what I will get, cd I will get, then b I'm writing here. After substituting c, still strings will be achieved. So first string is a. For d I need to substitute a. For b I need to substitute b. First production this one, and second one is this one, and third one is this one. Okay, before that I am substituting b, sorry, a. Okay, these are all the derivation we have already discussed. Okay, now what production involved for this means a tends to cd. Right, next production I need to go for id is a tends to cd. I should not see from here and go for the id representation. I should go for from the derivation. Okay, derivation only I need to go for stack implementation, id representation and simulation. All right, derivation, through derivation only we need to perform all those things. All right, not from the given set of productions. Next productions to be taken is a tends to cd. Okay, a tends to cd, I need to look on this diagrammatic representation. What they are saying, they asking you to first pop the a element, then need to push the d, and need to push c element into the stack. First we'll try to perform the pop operation. Here I'm performing the second production in which I'm performing pop operation. It is pop B. Sorry, pop A. Right, pop A I'm performing. So I'm writing same state as here, and I don't know the what are all the inputs, and I need to write the top element. Top element is A. Just I'm writing A, and in which I'm writing the same state as LHS. And now I'm writing the status of the stack. The status of the stack is I'm popping the element A from the stack. After popping out the A from the stack, my total number of elements is B Z naught. Right. B Z naught I'm writing here. Right. Then what have to do?
Push.
Yes, push D, push C. Right. Push D, push C. First I need to do the push operation of D. Right. So I'm writing push operation D I need to do. Okay, I'm writing state, same state. I'm W as the same set of inputs, and B should be the top element of the stack. Yes, B is the top element of the stack. In this side there is no resultant state, so I'm writing as same. And here I need to write the status of the status of the stack, so that I need to perform the push operation D. Right. If I perform push operation in this, I need to push the D here. So I am pushing the D into the stack. Okay. After pushing D into the stack, my status of the stack is D, B, Z naught. Right. Then what I have to do? Then I need to push the C element into the push the C element into the stack. Okay. Yes, I'm writing same as before. On the third one, there is will be the changes. Okay, that is the top element to be right here. The top element is D, so I'm writing D here, and in which the states same as before. And the second attribute, we need to write the status of the stack after inserting the C element. If I see insert means the total number of elements will be look like C, D, B, Z naught. Okay, that thing I need to write as a second attribute of the RHS. Yes, I have completed the second production ID representation. Okay, next what I have to do, what thing I have to take as a production. I need to go for the derivation. Next, what production they need to take? C tends to
Yes.
production have to take for ID representation. C tends to A in the sense C tends to A in the sense what we have to do. First we need to pop out the C element from the stack, then have to perform the read operation. What I have to do for the C tends to A production, first I need to pop out the C from the stack, then I need to read the A from the input tape. In this I'm removing the C element from the stack. So yes, the two things are same as before. The third one is top of the element. Top of the element is C. So I'm writing C. In this, I need to write the status of the stack. Second attribute, you look at. Second attribute in the sense, I'm removing the C from the stack. After removing, the status will be DB Z naught. That's thing I'm writing here. Okay. Next, what I have to do is I need to perform the read operation. I need to perform the read operation, that is A to be read by the head pointer. Okay, so this time only the set of elements, okay, that to be visible by the head pointer. Okay, now only the read A means the total number of inputs may be A, B, B. Okay, in which the first one will be visible to the head pointer. So I'm writing here as A. Okay, I'm writing here as A. Read A means I should write the string to be read by the head pointer. Okay, and then third one is top of the element. Top of the element is D. So I'm writing here as D, and right, in which, yes, look at here, in which the inputs are enabled. Okay, the inputs are enabled, that is which is visible by the head pointer. So whenever the inputs which is visible to the head pointer, definitely head pointer pass that input to the finite control. Finite control do the processing in the sense the final control generate the next state. So for A, then the resultant state will be Q naught. Okay, for B the resultant state will be Q1. Okay, if there is a C inputs available means then the state to be is Q2. Here there is a no chance of getting the input C, so the last one is null string. For null string the resultant state will be Q2. Right, I'm reading the input A for the state Q, so my resultant state will be Q naught. Right, for A my resultant state will be Q naught. Right, here just I'm reading, I'm not performing anything here, just I'm reading. So there is no operation to be done in stack because I'm not performing push operation, pop operation here. Okay, yes, next step I need to perform. Okay, this is the ID representation for the production C tends to A. Next I need to perform the ID for some other production. Next production what have to come is, what production have to we should take for D tends to
D tends to A.
A. Okay, in which D tends to A, D tends to A, in which I need to perform the pop operation. Okay, for this LHS will be the previous state. Here I need to represent as current state. So I'm represent current state as Q naught, and here I don't know what are all the strings here. Okay, because whenever I perform the read operation, then only that element will be visible to the head pointer. Okay, now I'm performing the pop operation, that is pop D. So the top of the element I'm writing here as a D. Next, okay, there is no transition performing here because there is no input here. So I'm writing as a previous state here as Q naught. So I'm writing the same state current here. And next one is here only I'm performing the pop operation, right? Yes, if I'm performing the pop operation of D means the remaining element in the stack is B Z naught. So I'm writing B Z naught. Okay, then in this step I'm performing the read operation, read A, right? Read A. So the A will be enabled in the input tape, that will be visible to the head pointer, right? So there is a transition will occur. Okay, the third one is top of the element is B. In this RHS, is if A is processed with the state Q naught, the resultant state will be Q naught. Okay, then I need to write the status of the stack. The status will be same status as previous step. So I'm writing here as B Z naught. And the next one I need to take some other production, okay, for representing the ID. Next production what I have to take, next production I have to take is B tends to capital B tends to small b.
Small b.
Okay, here I'm performing the ID representation for the production B tends to small b, capital B tends to small b. Here in this I need to perform the pop B, right? Pop B, this the status same status Q naught. And the next, in this point I can't able to view the inputs. And the next one is top element is B. Okay, I'm writing B, and this in which I need to write the Q naught. Okay, there is no new state is produced, so I'm writing the same state as Q naught. And here I'm performing the pop operation. So already B is present in the stack. I'm performing the pop operation, pop B, then B will be removed from the stack. The remaining element is Z naught, that is written here. Okay, the next I need to perform is read B. Okay, read B. Read B means that time the input will be visible by to the head pointer. Okay, so if A is processed with the state Q naught, okay, the resultant state will be Q1, right? So there will be no change in stack because we are not performing anything in the stack. Okay, yes, with this I have finished all the production representation of ID. Then last one I need to perform is final state ID representation, right? Final state ID representation. Okay, the head pointer read all the inputs. Okay, read all the inputs, then it is confirmed by, okay, reading the, it is confirmed by reading the null string. Okay, so for that I need to mention here is null string. Okay, null string to be read by the head pointer. Okay, so I'm writing here as null string. Yes, after processing, okay, just after processing, then the resultant state will be Q2. The status of this stack is same as here. Okay. The final state, for final representation, what we have to do, what we have to do, we should we should pop we should pop null string from the stack and then read null string from the input tape and finally reaches the accepted. Here there is a no null string which is present in the stack, so we need not to perform the pop null string, right? Uh, so that I'm neglected the pop null string operation and straight away I performing the read null string operation. Okay, so that only I performed the read null string operation. Okay, for final string there is two step, pop null string and then read null string. All right, head pointer which confirms that all the inputs are read by reading the null string, right? For that only I'm performing here step, but in formally for reaching the final state, the final step also they have given us a read null string. Okay, conceptually we should think that the head pointer which confirms all the inputs are read by the head pointer through reading the null string. Okay, the pop operation we are not performing here because in this stack there is a no null string present, so we usually will not use to perform this step. Suppose if there is unknowingly null string is present in the stack, means that time we can pop out the null string from the stack, but here we are not able to see the null string in the stack, so we ignore this step and we'll go for the next step, that's read it. That's the thing we have did here. Okay, after reading this one I got the next resultant state. The next resultant state is q2, right? For reading the null state the resultant state is q2. Yes, I have written, and status also I have written. Okay, once i have I have read the null string. Okay, I have to check the status of the stack. The status of the stack is also empty. The both the conditions are satisfied. Then I'm saying this Q2 is the final state. Okay, that through the reaching the final state Q2, the input which have taken AAB, which is accepted by the PDA. Right. This is the ID representation. Next, we will look at simulation. Okay, simulation in the sense, in first step alone we will have LHS tends to RHS, and next step onwards we will have only the RHS. Okay, in LHS first we will write the state, and then second we will write the total number of inputs that going to read by the head pointer. Next one is initially we are writing this top element of the stack. Okay, in RHS we are performing the all the operations. Okay, performing all the operation in the sense we should take the productions. Okay, productions I need to process in terms of simulation. Okay, first production I need to take is first production I need to take is S tends to
AB.
AB. Right, what I have to do is I need to push the S into the stack. So I'm pushing the S into the stack. Initially, there is only one element present in the stack. Is it not? After performing the push operation of S, stack will be like this. S is it not? Okay, my stack will be like this. S is it not? Okay. Next, Next I'm performing what I have to perform. Then I need to
A
perform pop, yes. Right, I need to perform the pop, yes. In this diagram, see, first we need to push the S element in the stack, and after that we need to perform the pop operation. We should pop the pushed element, recently pushed element from the stack. So I have completed this step, and then I need to perform the next one, that is pop, yes. Yes, in this in this step I'm performing the pop operation. Okay, pop operation, the s will be removed from the stack, and the remaining will be writing here as z naught. All right, in second attribute, which will be the element, processing element. Okay, this is the set of elements other than the processing element. All right, here we are not processing any inputs here. Okay, so I'm writing all the element here. All right, if I suppose I'm processing a, means in this step I'm reading the input, means in the second attribute, in this step second attribute, what I will do is remaining the processing element, I will write all the elements as the second attribute. Here in this remaining elements a means in this line I will write a. Other than reading element, I will write remaining element. Here I'm not reading any element here, just I'm performing the push operation, pop operation. So in this attribute I'm writing the full set of elements. So I'm writing here as AAB. Right. In this step, I'm performing the push operation of B. Right. I'm performing the push operation of B. So I am inserting the B into the stack. So after inserting B into the stack, my stack will be B Z naught. Okay. Then I need to perform the push A. I need to perform the push A. Right, in this step I'm performing the push operation. So if I push A, means the A will be insert in the stack. So my status will be A is A, B is Z naught. Okay, next what I have to do, I have to take next production. The next production is A tends
A
to
tends to CD.
CD. A tends to CD. So in which I need to perform the pop A operation. So in this step I'm performing pop operation. So the top of the element is A. So the A will be pop out from the stack. The remaining things is B Z naught. Okay, so I'm writing here as B Z naught. Okay, remaining attributes remain same as before step, because we are not reading any input here. While we reading the input, okay, the first attribute, second attribute get changes. Okay, other than reading the inputs, we need to look at only the third attribute only gets updated. Okay, in this step what I have to do is I need to push the C element into the stack. Okay, I'm pushing the C element into the stack. So pushing in the sense I'm pushing D. Already B is present, is it? That's thing I'm writing here is third attribute. Okay, next I'm performing pushing the C element into the stack. So I'm pushing the C element into the stack. C is pushed. Okay, this thing I'm written here. Okay, next, yes, this production is over. Okay, next I need to perform the next production. What is the next production in the sense? C tends to A. This is the next production. Alright. C tends to A in the sense, first I'm popping out the C from the stack. So C is removed from the stack. Okay, C is removed from the stack. So remaining element in the stack is BD Z naught. Okay, that's thing written here. Okay, next, in the next step I need to perform the read operation, read A. Okay, read A in the sense I'm reading the A element. Okay, remaining thing to be written here. Okay, remaining element is AB. Okay, now only I'm reading the input A, so remaining element to be mentioned here. Okay, while reading A, my resultant state I have to mention here. Okay, for reading A, my resultant state is Q naught. Okay, so I mentioned here is Q naught. Okay, before that and all I have mentioned only the Q. Here only I mentioned as Q naught. Okay, the remaining element I have read here, I have written here AB, and here there is no change in stack because there will be processing in the input tape only. Okay, next what I have to do, I need to perform for the next production. Next production is D tends to
D tends to A.
A in the sense so in which I'm performing the pop D operation. So D will be removed from the stack. The remaining elements are B Z naught. So I written here B Z naught. Then I'm reading the next one, that is read operation of A. So while reading, okay, I'm reading the A. Okay, I'm reading the A. For reading, the resultant state will be Q naught, and while reading A, the second A, the remaining element to be written here. The remaining element is B, so I'm written element B. Okay, next I need to write status of the stack. The status of the stack is remains same. The next production I need to take on. The next production is B tends to
Small.
capital B tends to small b. Okay, in which I need to perform the pop operation. So the top of the element B is present, that B will be removed. Okay, remaining will be Z naught. So I'm writing here as Z naught. Okay, the next will be read operation. Okay, read B. Read B in the sense, okay, I need to read the B from the input tape. Okay, while processing, the resultant state for B is Q1. So I return Q1. Okay, and after reading B, okay, the second attribute what I have to do is remaining element to be read by the head pointer I need to write. Okay, is AAB read by the head pointer. The next element to be, the remaining element to be read by the head pointer is null string. So the remaining element to be read is null string I have mentioned here. So there is no change in stack. So the element I have written is same as before one. Okay, next with this the ID representation for B tends to be over. Okay, next we need to go for representing the final state, that is accept state, in which what they have given is pop null string, right? There is no pop element, there is no null string is present in the stack, so I need not to perform the pop operation. You want to mention as performing the pop operation, just you try to mention. Okay, no issue. I have not mentioned here because I'm not performing this operation, so I am not mentioned here. You want to mention, yes, you can mention, no issue in this. Okay, so I'm not performing this pop operation, then I'm performing the read null string operation. Okay, the read null string in the sense, okay, just I'm reading the null string. Okay, for reading the null string, my resultant state is Q2, and after reading this one, there is a no string to be read by the head pointer. Okay, so I have not mentioned the second attribute here. Okay, The second attribute is vanished and which is replaced by the third attribute. Okay, which means that second attribute is empty. The third attribute I need to mention, third attribute is status of the stack. The status of the stack is empty. Okay, in this step, the inputs which is read by the head pointer, that is the head pointer points the input null string. Okay, and the same time stack also empty, the stack which has the only one element, that is z0. Okay, when both the conditions are satisfied at a time, okay, then we are saying this, we are reached into the accepting status, final status q2. That is the aab, we have taken the input in the input type that will be read by the head pointer, and while processing this, which is which is accepted by the PDA. Okay, these are all the four ways of representing the CNF. Okay, first one is graphical, that is diagrammatic representation. Second one is stack implementation. Third one is ID representation. Fourth one is simulation. Okay, the next example is construct PDA for the given CFG. Okay, yes, look at this production. Okay, this production are ordinary CFG productions. Okay, here we can able to design PDA only for the CNF. Okay, we can't handling the topic CFG and all. Okay, we are looking PDA for CNF. Okay, but in this situation they have given you the CFG. Okay, what you have to do is you have to make this production in terms of CNF. Okay, then you consider this CNF, okay, as the actual production, and for this CNF production you have to go ahead for the four representation in the sense graphical representation, that is diagrammatic representation, and stack implementation. Third one is ID representation. Fourth one is simulation. Okay, these are all the things you should go for designing PDA, right? See, in this we have to change into CNF. Okay, first we have to change all the terminal into non-terminal. Okay, for that I'm introducing the two new production, that is R, that is A tends to A, capital A tends to A. For B, I'm introducing the production, that is R2 tends to B. Okay, so in this place I'm replacing all the terminal into non-terminal. So I'm writing here as A. Okay, for this small a I have replaced capital A. So I'm writing capital A. Its S is already capital. So I'm writing as S. This B I have introduced one production, that is R2. So I'm writing here as R2. Right? Yes, all the productions have converted into non-terminal. Okay. The CNF format I need to check on. The CNF format should be a single terminal or it should be a two non-terminal. Right? Here I'm making to have all the CNF in terms of non-terminal. Here in RHS all the variables are non-terminal, but it should be the two non-terminal. But here it looking like three non-terminal. So I need to again simplify this one into two non-terminal. So for making simplification, I'm go for one more new production. Okay, one more new production in the sense I'm introducing this production. Okay, I'm introducing this production. R1 tends to S R2. For instead of this S R2, I'm going to replace the variable R1. So I'm writing R1 instead of this two non-terminal. Yes, now I'm looking this. Now I'm looking this. Yes, this seems to be CNF. Yes, first production. First production I've made in terms of CNF. Okay. The second I need to look on. Okay, the second production is it's also is not CNF. So I need to convert this thing into non-terminal first. Yes, I have already introduced the productions for A and B. Okay, for A, for small a, I have introduced the production A. So I'm writing here as A. For B, production is R2. So I'm writing here as R2. Yes, this one, after replacing, this one seems to be what? Seems to be CNF. All right. Yes, second one also I have made in CNF format, and second one also I made CNF. Okay, while making all the productions in CNF, the intermediate productions have introduced, right? The intermediate productions have produced. Okay, that I need to look on that is in CNF or not. Okay, that I'm looking here, all the productions are CNF. Suppose it is not CNF, I have to convert this production into CNF, right? For converting this production into CNF, what are all the productions which helped us? Okay, that also I need to consider CNF productions. Okay, my total CNF productions are, this is the first one. Okay, this is the first one. Okay, this is the second one. Okay, the second one. These are all the supporting productions. Okay, so I'm taking this set of productions is the final one, because these productions are all in form of CNF. So I need to represent PDA. I need to design PDA. For PDA designing, I need to go for four things. What are all the four things? First one is diagrammatic, the second one is stack, third one is ID, the fourth one is simulation.
Simulation.
Okay, first we will look at the diagrammatic representation. Okay, first, first we try to represent the set of productions in graphical notation. Okay, that is the first production. It always has the start production, that is initial production, that is initial state. Okay, and also has the ordinary production. Okay, remaining this first production, every production is considered as the normal one. But here only, first production only, I need to consider this as start state and also the normal production. Okay, so what I have to represent is, I need to start with start. Okay, then push S, then push S, then push S. Okay, this is the way to represent the start symbol. Okay, at last everything has end up with pop. Okay, so the pop mentioned here is pop yes. So mentioning here is pop yes. Okay, start symbol, push yes, pop yes. Then what I have to do, I need to look on RHS. Okay, RHS, in which what have to do? In which have to do the pop S and then push R1, push A, right? Yes, already we have did. Already we have did the pop yes. Next I have then have to do the push R1, then push A. Then I need to join this in pop. Next what I have to do is again I need to perform the pop yes, push R2, push A. This is the pop yes. Okay, pop yes, push R2, push A. I'm joining this into pop. Next one is, next what I have to do is pop R1, push R2, push S. Pop R1, push R2 and push S. I'm joining to pop. Okay, next what I have to do? Next what I have to do? I have to pop R2 and then read B. Okay, pop R2 and read B. This is pop R2, read B. Okay, then I need to join to the pop. Next what I need to mention is read A. Okay, read A. That is pop A, read A. Pop A, pop A, read small a. So I'm joining here to the pop. Yes, all the productions I have represented. Okay, last one I need to represent is final state. Okay, final state what I have to do is pop null string, read null string and accept. Okay, pop null string, read null string, accept. Okay, this is the diagrammatic representation of given CFG. The model which we are going to design, it's is up to the designer, right? But the syntax to be followed is correct. Okay, next one is stack implementation. For performing stack implementation, I need to go for derivation. Okay, through derivation only, okay, remaining things to be done. First one is stack, second one is ID, third one is simulation. Okay, the three things should process based on the derivation. Okay, uh, first take all the production. Okay, all the production in the sense first one is s tends to AR1, s tends to AR1. Second production is s tends to
Essence to
AR2,
yeah to
AR2. Third one, third one is R1
R1 tends to
to SR2,
SR2
R1 tends to SR2,
R2
R2 tends to B,
tends to B
R2 tends to B and A tends to small a. Okay, these are all the productions. Okay, with this production we will try to derive the first production to be taken is A R1. Okay, in which try to substitute. First I need to go for S, F substitution. S substitution, since I have the direct substitution, so I'm substituting here A. Okay, next I need to substitute for the variable R1. Yes, for R1 I'm having this production, so I'm substituting S R2. Right, for S I need to go for substitution. Okay, I have 2S. Yes, I have 2S. You can go for any representation. Okay, okay, let me check this first one. Okay, A R1 R2. I'm checking the first one. Okay, again I need to go for substitution A. If I go for substitution A, yes, direct A I'm substituting for R1. Okay, I'm substituting this production. Yes, R2. Yes, I will write one by one so that it is easy. For R1, we'll take S R2, then I'm taking R2. Right. If I take, listen, if I take S for the substitution A R1, first one. Okay, there is two substitution to be substituted in the place of S, right? If I taken this one, okay, it goes for more number of derivation to attain the total number of strings. Right. For avoiding more number of steps to getting the total number of string, I'm going with this production substitution. Right. If I substitute, yes, this production means my substitution will be A A R2. Right. A R2 and remaining is R2. Right. Okay. For A, I'm substituting the direct production A and I'm writing remaining production. Okay, next thing to be substituted is R2. For R2, I'm having direct substitution B. Okay, the next thing to be derived is R2. Yes, I R2 also I have a direct string. So I'm writing here as B. Yes, in less number of steps itself, I'm getting the string of the CFG. So that for substituting, yes, I have two productions, from which if I taken this one, it's getting more number of steps to attain the string. So I avoided substituting this one. Instead of substituting this one, I'm taken the second production for substitution. For this substitution only, I got the strings in less number of steps. You want to use this production and you want to get lengthier number of steps to attain this thing, yes, you can go for this substitution. You can go for substituting this production to get these things. Okay, for avoiding um, more number of steps, okay, I'm substituting this production in this point. Okay, derivation is designer choice. Okay, how they are using derivation to attain this thing, okay, that is up to the designer. Okay, in shorter way they want to get the string, or in more number of steps they want to get this string. Okay, that's up to the power of the designer, capable of the designer. So I have derived all the string. Okay, why I have derived all those string? For representing the stack representation, right? For knowing the step by step production involved for the stack. What is the first production involving the stack? First one is S tends to A R1. This is the first production. Next production involving is A tends to capital A tends to small a. Okay, next production involving is R1 production, that is R1 tends to S R2. Next production involved for the stack implementation is என்ன production next involve ஆகுது? S production இல்லையா? S tends to A R2, right? Next production involved is A tends to capital A tends to small a. The next productions involved is R2. Okay, two R2 is involved. First one is R2 tends to B. Next one is R2 tends to B. Okay, these are all the productions involves step by step. Okay, to make stack as the empty and input which is read by the head pointer. Is it clear? Derivation is clear for you? Derivation topic and all we have already discussed. In this representation of the 3-1, okay, we are go for leftmost derivation, right? In derivation we have two types of derivation: leftmost derivation, rightmost derivation. Okay, in which we are taking all the string for the, that is we are taking all the variable for the derivation is leftmost variable. Okay, if you take the two variable for the substitution, what variable we are taking for the substitution? Left variable only we are taking, in which we have taken all the left variable for the substitution. So that I'm saying this derivation is done by LHS method, right? You want to go ahead for RHS, yes, you can go ahead. Accordingly, the stack implementation, ID representation, simulation will differ.